Welcome to our tutorial showcasing the remarkable capabilities of math.ceil and math.floor functions in managing financial data impacted by inflation. In this tutorial, we will delve into how these functions enable precise rounding of inflation-adjusted values, revealing the intricate dynamics of monetary depreciation over time. By the end, you will appreciate the significance of accurate rounding in financial analysis and planning. The first line defines a variable named annual payment, representing the payment or income received per year. In this case, it is set to $15,000, indicating an annual payment amount. The next line defines another variable named annual inflation, representing the inflation rate for the entire year. It is expressed as a percentage, 5.9%, indicating the expected increase in prices or decrease in the purchasing power of money over the course of a year. This line of code calculates the inflation rate per month based on the annual inflation rate. The annual inflation rate is divided by 12 to get the monthly inflation rate. This division accounts for the fact that there are 12 months in a year. Then, dividing by 100 converts the percentage value to a decimal. So, for example, if the annual inflation rate is 5.9%, this line calculates the monthly inflation rate as 5.9 divided by 12 divided by 100, which is approximately 0.49%. This represents the expected increase in prices or decrease in purchasing power for each month due to inflation. Next, our code calculates the decrease in the value of money per month. Multiplying the annual payment by the monthly inflation rate calculates the amount by which the value of the money decreases each month. For example, if the annual payment is $15,000 and the monthly inflation rate is 0.49, means that the value of the money decreases by approximately $73.50 each month due to inflation. Here the code calculates the decrease in the value of money over the course of a year. Multiplying the monthly decrease by 12 calculates the total decrease in the value of money over the span of a year. Since there are 12 months in a year, this multiplication accounts for the cumulative effect of inflation over each month. For example, if the monthly decrease is $73.50, then 73.50 multiplied by 12 means that the value of the money decreases by approximately $882 over the course of a year due to inflation. This piece of code is designed to round up the calculated decrease in the value of money per month and per year to 2 decimal places. The math.ceil function is utilized to round up the value of the monthly decrease multiplied by 100 to the nearest integer. By first multiplying by 100, the decimal point is shifted 2 places to the right, enabling the ceil function to round to the nearest hundredth. Then, dividing by 100 restores the decimal point to its original position, effectively rounding up the result to 2 decimal places. This rounded up value is stored in the variable monthly roundup. Similarly, the next line applies the same rounding process to the value of the annual decrease multiplied by 100, ensuring rounding up to the nearest integer using math.ceil. Again, the multiplication by 100 and subsequent division by 100 ensure rounding to 2 decimal places. The resulting rounded up value is stored in the variable annual roundup. In summary, these lines ensure that the calculated decrease in the value of money per month and per year is rounded up to 2 decimal places, providing more accurate and precise results for analysis and presentation. Here, by directly multiplying monthly inflation by 100, the code accurately calculates the monthly inflation rate as a percentage. However, this approach retains the decimal precision of the original value, which may result in a percentage with more decimal places than typically presented. Given the sensitivity of financial calculations to even small changes in percentages, maintaining this precision could be important for accuracy, especially in contexts where the exact percentage value is critical for further analysis or decision-making. Therefore, the code represents the monthly inflation rate without rounding to 2 decimal places, prioritizing accuracy and precision in the calculation over presentation aesthetics. Our next lines provide a clear presentation of the calculated decreases in the value of money per month and per year, ensuring that the values are rounded up for better clarity and accuracy in financial analysis. Next lines of code round down the calculated decrease in the value of money per month and per year to 2 decimal places. Rounding both up and down allows for a more comprehensive analysis, enabling comparison between the rounded up and rounded down values to determine which rounding method is more appropriate or convenient for a given scenario. By providing both rounded up and rounded down values, the code facilitates a comparison of the potential impact of inflation on financial calculations from both a more optimistic and a more conservative perspective. This comparison can help decision-makers choose the rounding method that aligns best with their goals, risk tolerance, and overall strategy. Therefore, rounding both up and down provides valuable insights into the potential range of outcomes, empowering users to make more informed decisions based on their specific needs and preferences. This tutorial demonstrates how math.ceil and math.floor can be used to round values to achieve different levels of precision. The precision is crucial in financial calculations where small differences can have significant impacts. These functions provide versatile rounding options. Math.ceil rounds up to the nearest integer, while math.floor rounds down. This versatility allows for fine-tuning calculations to meet specific requirements. By rounding values both up and down, enables a comparative analysis, allowing users to assess the potential impact of rounding on financial outcomes. This comparison empowers decision-makers to choose the most suitable rounding method based on their objectives and risk tolerance. By providing insights into the consequences of rounding choices, users are better equipped to make decisions aligned with their goals and strategies. Overall, the tutorial serves as an educational resource, showcasing the practical application of math.ceil and math.floor in financial modeling. It highlights their power in managing and presenting financial data accurately and effectively.